Hi there, just showing a digital clock created by using a Raspberry Pi and its GPIO outputs. So this is my Raspberry Pi clock, and I'm just going to show you how it works. And as you see, it's showing time to be 4:34 p.m. and it's got 4 digits. So you can see the 1 here, 6 and 3 and 4, and it's using the Raspberry Pi here. Got the ribbon cable, Raspberry Pi ribbon cable, and it's powering 7 segments. All 4 of them, the 7 segments are in parallel, and it's also switching on 4 transistors which control the 4 individual 7 segments, individual modules here, 7 segment modules. And I think I'm just going to slow down for you just so you can see what's going on. Just going to change the code here. And set the delay to slow. Too slowly. You see it's showing 1 digit at a time. Okay. So it's actually switching on one segment at a time, 1 digit, 1 LED at a time, and there's 4 of them, so that's 7 times 4. There's 28 LEDs, 1 LED at a time. And I think you can speed things up a little bit. And you can see it looks like it's it's switching it fast enough that it seems like 4 solid segments there, 4 solid digits. Okay, so now it's even more solid. So I'd just like to show you actually resources. So this clock, and actually here's the code. Let's load it. And it's written in perl. You can see the CPU is pretty intensive there. 13% CPU. It actually could be higher. I should actually show it to you. Higher. If it were more solid, if I were to display the LED with no delay, the switching with no delay, you can see that the CPU is quite high. It's like 73% now, 72%. So the clock is actually very CPU intensive because it's switching 1 digit at a time in a matter of microseconds. and actually let me show you some of the code here. This is, once again, it's written in Perl, and it's using the module called the BCM2835. And first you got to install a C library, and it's actually just reusing the C module, C libraries. Okay, so that's the function that does the switching. Okay, so purpose is just to demonstrate GPIO, Raspberry Pi GPIO switching, and using it to control 4 7-segment LEDs to create a clock. And it is a real-time clock, and I actually froze it just so I could show you the time. Alright. So that is the time, and what's happening is it's just demonstrating multiplexing to demonstrate switching, rapid switching to demonstrate a persistence of vision. So when it switches very fast, you can't tell that it's switching. As you can see here, it's switching in a matter of probably microseconds, a few kilohertz. So you can't see that it's switching. Once again, it's switching 1 digit at a time, and just to demonstrate once again, it's switching 1 digit at a time, 1 segment one LED at a time, and it goes through 4 segments. And I do this to one of the other goals is to use as few parts as possible. As you can see, I'm using only the fewest possible parts, and that is one transistor per LED, per 7-segment LED per digit, 1 transistor, and 1 resistor for all the LEDs. And it is supplied, the power is supplied directly by the Raspberry Pi. From its 3.3 volt output, which is one of the pins here. It's actually right there. Pin 1 is 3 volts, and pin 6 is the ground, and I use a 150 ohm resistor here. This one here, black brown, is 150 ohms. And it's to the ground. Same thing on the other side. Actually, on the positive, I use a 1 kilo ohm resistor. And all 4 LEDs, the 7 segments, it's common cathode, and in all the 7 segments are all in parallel. So 7 segments here, 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 and here, all wired in parallel. As you can see, it's all across in parallel. And then the cathode is switched by the transistors, individual transistors. and so it goes across at that one transistor at a time. And already in my previous videos already showed the circuit diagram, so I'm not going to keep repeating it. Okay, there's my clock. And I think I want to show you just one more thing. Yeah. I'm going to speed up a little more again. And okay. One of the goals, I just switched it to the actual time here. And one of the goals I want to do is add 2 more digits for seconds, and then more digits for the date. And in the future, I'd like to try probably some matrix, like a dot matrix, like an LCD dot matrix. I'm looking to a few of them. I'm looking to one of them at that you can get at adafruit.com. Because they have some very nice ones there. And they have LED matrices too, where it's powered by 4 pins, and on the back of the modules they actually have processors on there. But for now, I'm going to do the primitive way. It's few parts as possible. And this cable I got on eBay. The GPIO cable on eBay, and you can actually use any IDE cable. So you can use any IDE cable and it'll actually fit. Okay, because before, what I did before was just cut the other end, solder and tin the tips, and just plug them in. And I found that it's actually very cumbersome to plug and unplug on these solderless breadboards, even, because eventually they start fraying and bending. And so I decided to finally spend the I think it's like $6, $10 for the cable and the module, because it was very solid. I didn't feel like soldering all that. The header and the pins and everything were already soldered in. It's already soldered in there, color coded and everything, so it's already done. Done on eBay.